Reducing energy consumption is a major concern for many people. One popular way to do this is to change your light bulbs, and maybe you have some compact fluorescent light bulbs in your home. Corrine Tate from the museum is here to talk about energy-efficient light bulbs and to tell us about lighting options in our near future. Hi, Corrine.
Hi, Brenda.
Do compact fluorescent light bulbs really save us a lot of energy?
They do. I think a lot of people are surprised to hear that 22% of the energy consumed in the United States actually goes to provide lighting. So if we have better light bulbs that use less energy, it actually does make a very big difference on our energy use.
How much more energy are we saving by using CFLs versus the regular light bulbs?
The CFLs use about 70% less energy than the regular incandescent bulbs. So it is definitely a significant difference.
That is significant, but you actually know about new technology that may even move us past these more efficient compact fluorescent light bulbs into an even more efficient world.
Exactly. These new bulbs are called LEDs, which stands for light emitting diodes, and they use 80 to 90% less energy than the incandescent bulbs. So you are actually saving even more energy than using CFLs.
Okay, now I've heard of LEDs. They're not super brand new, right? Light emitting diodes, they're currently in use in some signaling lights and some other nice, bright, shiny signs.
Exactly. They've been around for a few decades. Initially, they could only really make red LED lights, so they were used mostly for indicators or signal lights. But we've been able to make the color from LED lights into a much broader array, and they've come out with white LED lights, and now they're starting to be used for illumination or lighting as well.
Sure, there's lots of flashlights that use LED lights and maybe even car headlights.
You're absolutely right. They are used, and more municipalities that are trying to save money are using LED lights in outdoor lighting.
I know I've seen these everywhere. They're quite bright, so they're certainly eye-catching, but I also feel that they're a cold light. They have a cold color to them.
Exactly. That's the problem with the LED lights. And it's a problem that actually a lot of consumers complain about the CFLs as well, that these more energy-efficient light bulbs, whether they be CFLs or LEDs, they create that harsh, sterile white light. It's not a very warm, appealing color. And people are turned off by the unflattering color, and that's why some people are reluctant to switch to these more energy-efficient bulbs.
Why is it that the energy-efficient bulbs give off a cooler color?
Well, it has to do with how they produce light. An incandescent light has a wire filament that runs through it, and when electricity goes through the filament, it heats it up until it creates light. But it's creating light and heat, which is why it's using a lot of energy. But it creates that nice warm glow that we like. More energy-efficient light bulbs, like CFLs, create light a different way. A CFL bulb has a combination of argon and mercury vapor inside the bulb. And when we send an electric current through that gas, it excites the gas, generating a UV light, or invisible UV light. And on the inside of the CFL bulb is a phosphor coating. And when the UV light excites this phosphor coating, it generates the white visible light that we see from the CFL bulbs. But the phosphor coatings are really producing this very harsh, sterile white light as well.
So there's argon and mercury gas in the CFLs, and that's what's producing this white light, as opposed to heating a filament in our regular incandescent light bulbs. But how do LEDs work?
Well, LEDs are a semiconductor light source. So the way a semiconductor emits light is the electric current drives a lot of the electrons in the semiconductor into a higher state or a more energetic state. And as they fall back to their original energy state, they emit photons, which is light. So they're emitting light by the movement of electrons in this semiconductor material.
But still, for LEDs, that photon light emittance is not produced in the sort of warmer spectrum of light. It's still that cool color.
Exactly. It's that cool color. And to really get people adopting these more energy efficient bulbs, we need to get a more warm, appealing color out of these energy efficient bulbs.
Well, is it possible to tint the bulbs to have them produce a warmer color?
That's a good point. And you can use a filter or a colored lens to color the light. The problem is a filter or lens actually absorbs certain colors of light, so you're losing light energy, and then your bulb is less energy efficient.
Right, so that defeats the purpose. It
Exactly.
gets you a good color, but defeats the purpose.
And another way they use it is instead of having the phosphor coating that we see in our CFLs, you can use a different phosphor coating, a red phosphor, to create that warmer light. But again, you're losing some of that energy efficiency in creating creating that warmer spectrum of light.
Okay, so there's definitely a market, an opening here for a warmer type of efficient light bulb.
Exactly. And this company, a local company in Watertown, Massachusetts, was started by several graduates from MIT, and they were working with quantum dots. And they figured out a way to use quantum dots to create this really nice color quality on energy efficient LED bulbs.
Okay, now you're going to have to tell me what a quantum dot is.
A quantum dot is a tiny nanocrystal of semiconductor material. When I say tiny, I mean they are just a few nanometers across. And what the quantum dot does is it emits light of a certain color. When it's excited by some kind of UV light or visible light, it glows or it emits this light. And what controls the color of the light it emits is just the size of the quantum dot. So quantum dots that are very, very small emit blue light. Quantum dots that are a little bit bigger emit green light. And the biggest quantum dots emit red light. So it's exactly the same material, but if you change the diameter of the dot, it changes the wavelength of light that's produced.
And how much is the diameter changing between red, green, and blue semiconductor emitting light?
I believe that the smallest crystals are about 1 or 2 nanometers across, and the larger crystals are about 8 to 10 nanometers across. So it's within a pretty small range. I might be wrong on those diameters, but it's in that range.
It's a very tight range. And
exactly.
It's possible then, at least with one type of semiconductor material, to produce 3 different colors in this very small size range.
Not just 3, it could be even many more.
Okay, so it's possible to get a lot of different colors, just changing very slightly the size of this semiconductor material. Is it difficult to make these quantum dots?
Actually, there has been a really big breakthrough. QD Vision has made a huge breakthrough in figuring out a new way to make quantum dots. Quantum dots are used in a lot of different research at a lot of universities, but they're made in very small batches, and they tend not to be very stable. They don't last for very long. And what really brought QD Vision into the forefront of this industry is they've created a new technique that they're keeping under wraps, but they're able to make huge quantities of quantum dots and make quantum dots that last a very long time, so are very stable over years and years and years. That's why this is one of the first commercial applications of quantum dots.
So they've taken their quantum dots and produced a light bulb that's energy efficient and can bring out a warm color.
Well, actually, QD Vision isn't making the light bulb itself. What they've done is they've used the quantum dots to create an optic piece that fits over the exit face of an LED light bulb. So they focus on making these optic pieces that have the quantum dots that emit this nice warm color, and they're working with a variety of lighting partners that create LED bulbs. So their product will go with these LED bulbs. And the company they're working with right now, Nexus Lighting, is the first commercial partner. So it's the Nexus Lighting bulbs, LED bulbs, with the QD Vision optic component that are the first on the market.
Is there going to be one colored bulb that'll come out, or is there a variety of colors that they'll market?
Right now, they're just marketing a single color bulb that it's basically an LED bulb that gives that nice warm color quality that we expect and that we got used to with incandescent bulbs. So really, they're just coming up with an indoor bulb to compete with the incandescent bulbs that everybody likes and the CFLs that everybody uses, but isn't quite right with the color.
So how exactly do the quantum dots work with the LEDs?
Well, the LED is producing this bright light, this bright high-energy light, and it excites the quantum dots that are in the optic component. And then when the quantum dots are excited, that's when they glow. That's when they emit this light. And they've picked quantum dots of just the right size, so they're emitting this nice, warm, appealing light.
Okay, the LEDs are exciting the quantum dots, so it's sort of a two-step process, which may not make this light bulb more efficient than LEDs, but it will certainly produce a nice color comparable to incandescent bulbs.
That's a great point. These light bulbs aren't more efficient. They're basically just as efficient as the LEDs, so they don't lose any efficiency while making this nice appealing color.
So they're still a good option for people who are trying to be energy conservative, but might enjoy a warmer feeling in their homes or wherever they might like to use their light bulbs.
Exactly.
And it sounds like this product is basically ready for sale.
It is. They're shipping right now to the partners that will be selling these, and you're going to see them on the market in the next month or two.
What's the price on these bulbs?
These bulbs are pretty expensive. They run about $100 a piece, which sounds like a lot, but given that they last 15 years, they have 50,000 hours of useful life, which is 5 or 6 times better than any comparable light bulb, and even many more times better than an incandescent bulb. So even though it's a very high upfront cost, you pay off within about a year or 18 months on the energy savings and the longevity of the bulb.
Okay, so averaged over 15 years, $100 isn't so bad.
It's true that $100 price tag is really steep, and that's going to prevent people from using this. But you can expect that the LED lights will become cheaper. This is kind of the first technology, and new technologies are always really expensive at the beginning until kind of supply catches up. And a lot of lighting companies really see LEDs as the future. Philips, which is one of the biggest lighting companies, they think that in about 10 years, as much as 80% of the lighting market will use LEDs. Now, the only way that's going to happen is if the price comes down pretty substantially. The industry is certainly ramping up to be able to meet that kind of supply. So I think in the next couple of years, you're going to start seeing LEDs become a lot cheaper, and that's when we're going to see people actually start to use them in their homes.
All right. Well, we'll keep our eyes out for these more efficient but still pretty quantum dot lights and LED bulbs. Corinne, thank you very much for going through the science of lighting for us today and telling us about the future of lighting as well.
Thank you so much, Brenda. Anytime.
That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.